Welcome everybody, and thank you very much for attending the Virtual SAN Take 20 webcast series. My name is Roland Rivera, and I'm a principal architect in the office of the CTO for the Storage and Availability Business Unit. And in this episode 1 of the Virtual SAN Take 20 webcast, I'm going to focus and cover the Virtual SAN space efficiency features and capabilities that were introduced in the latest release. Virtual SAN is now in its 4th release, and here you can take a quick look at the list of data services features and capabilities that have been introduced until this point. The Virtual SAN 6.2 release introduced a number of important new features that are focused around space efficiency. Deduplication and compression are two of the new space efficiency features that are introduced in the latest release of Virtual SAN 6.2. Deduplication and compression are only supported in the all-flash configuration of Virtual SAN. Now, whenever we discuss the configuration of dedupe and compression, it's important to understand that in Virtual SAN, these features are considered to be what we call cluster-level features that are performed at a disk group domain instead of being performed in a global domain. This approach prevents the need for the system to perform global lookup functions and eliminate the need to use unnecessary system resources and introduce them as potential overheads to the system. Now, instead, this approach allows the system to efficiently use the available and necessary resources towards the tracking of smaller and meaningful block sizes to deliver overall better space reduction results. With Virtual SAN, you get both dedupe and compression as one feature at no extra overhead cost. The way in which we do this is based on the implementation of the features where they are designed to deliver the best results depending on the data or the workloads that are stored within the system. Now, what I mean by that is the following. If the workload is not deduplicable, then hopefully we have the ability to save space by providing or using compression to do so, and vice versa. So it's very important to understand that whenever the workloads are either deduplicable or non-compressed or not able to be compressed because of their data types, the system attempts one of the two simultaneously to actually deliver the space efficiency services that it's designed to do. Now, when it comes to some of the details around deduplication, deduplication is performed on a default fixed block length of a 4 KB chunk size. From a compression standpoint, this is performed after deduplication, and Virtual SAN uses LZ4 as its lossless data compression algorithm to deliver its compression capabilities fast and efficient. Now, for each unique 4 KB block that is compressed, if the output of that block size is less or equal to 2 kilobytes, a particular compressed block is saved in place of the 4K block. Now, if the output of the block size is greater than 2 kilobytes, the block will be written and compressed and tracked in such way. Now, the reason this is done is to avoid block alignment issues as well as to reduce the utilization of CPU. Deduplication and compression are features that are both supported in the stretch cluster as well as the robo configuration scenarios. So let's take a quick look at the demonstration of the configuration and setup of deduplication and compression on a Virtual SAN cluster. Here you have one single click to enable dedupe and compression from the Virtual SAN configuration wizard. Now, obviously, you can do this during the initial stages of the configuration or as a post-configuration process, depending on the settings of the cluster. Either way, you get to select and claim the actual disk types or the data type, how you want to select the different caches, the caching tier and the capacity tier. And after that, you can basically move on and enable the feature at the cluster level, which is a point that I was trying to make here. Now, when it comes to the identification of the compression and consolidation ratios, you can find that directly within the summary tab or in the new dedicated tab for capacity, which is under the monitoring feature of Virtual SAN. Here you can see all of the different settings and capabilities that are being deployed in Virtual SAN and what's consuming any sort of capacity. Very simple to configure and enable deduplication and compression, and also to track the values and results in terms of compression and deduplication ratios within the system on the newly improved and introduced interfaces, whether it's going to be directly from the summary tab or the dedicated capacity tab under the monitoring capabilities of the cluster. And now let's move on to another hot topic, which is the implementation of erasure codes. In Virtual SAN 6.2, we now offer a new capacity-efficient way to deliver data redundancy in the form of RAID 5 and RAID 6. These new capacity and efficient data redundancy methods are performed inline without the need of any post-processing required. With Virtual SAN design goal of not having to rely on data locality for persistence, this implementation of erasure code does not bring any negative results by distributing data stripes in the form of RAID 5 or RAID 6 across any of the multiple hosts within a cluster. These methods are capacity-efficient ways to provide data redundancy as opposed to the RAID 1 and RAID 0, which were performance-oriented mechanisms. Now, still, the users will still be able to pick the protection level they want, whether it may be FTT1 or FTT2, depending on the choice or the level of availability they may want to deliver for their application, but their choices will be made based on either performance or capacity. Now, the RAID 5 and RAID 6 erasure code implementation comes at a price or a cost. That cost is IOPS amplification and potentially higher latencies, which is part of the reason as to why these features are only supported in the all-flash configuration of Virtual SAN, which is the actual configuration that's able to withstand both the IOP amplification tax as well as the higher latencies within the systems, since no one application can consume all of the IOPS delivered by a Virtual SAN configuration. Unlike deduplication and compression, erasure codes guarantees capacity reduction, and now by being able to combine both of them, we should be able to deliver the highest level of space efficiency reduction within the system. Either we take the workload type efficiencies delivered by dedupe and compression and the guaranteed space efficiency by distributing the data across a larger number of nodes within the cluster. Combining those two delivers an overall better results, as you can see here in terms of how the data is distributed throughout the system. So let's take a quick look at the configuration of how erasure coding and how the RAID 5 and RAID 6 implementation is performed within the system today. So here we'll start by going to the VM storage policies, which is the same way in which we manage policies for Virtual SAN. I'm going to very quickly go and edit the default policy, which doesn't necessarily have to be the case all the time. Well, here you can see now that you want to add a new rule, and the new rule comes in the fault tolerance method. Here you can see that RAID 1 mirroring is based on performance, as I mentioned before, whereas RAID 5 and RAID 6, which is the erasure coding piece, is in the base of capacity. Very quickly on the real-time APIs functions and calculation here, you can see the impact on the space or the storage space that's going to be consumed depending on the number of failures to tolerate you choose to deploy within the system. That obviously doubles, or you can see those changes live, and you can choose to apply those new changes right there and then, or do them at a later point in time. Once those changes have been applied, you'll be able to identify the layout by going into the policy settings of any particular application, and you can very quickly see and identify that now the layout is based on a RAID 6 configuration. When it comes to space efficiency capabilities, here's a feature that is a core component of Virtual SAN 6.2, which may not be as popular as erasure codes, deduplication, and compression, but it does deliver an incredible amount of impact and value to the consumption of storage in Virtual SAN. Sparse swap is a feature that allows you to reclaim space used by memory swap. Now, this is a host advanced option that enables the settings of a policy for the creation of a swap file not to be created with the capacity or configuration for space reservation. Now think about it. When you are supporting an infrastructure that is composed of virtual machines with large memory footprints, whenever the virtual machines are powered on, the swap file that's created is based on either the reservation of memory or the calculation of limit minus reservation. Overall, a large number of virtual machines with a large amount of memory allocated to them can essentially consume a pretty large capacity of the storage infrastructure, and also here particularly when it comes to virtual SAN. You are now able to change that behavior by making it so that the system does not pre-allocate or reserve the capacity for these swap files and instead deliver it in a sparse format, in a thin format that overall allows you to use or make better use of your storage resources for longer periods of time. Let's take a look at some of the examples on how significant the space saving is when leveraging the sparse swap feature and capability within Virtual SAN 6.2. So let's take a look at this environment, this particular cluster here, and go to the capacity view. And notice that the amount of capacity being consumed by swap is in the terabytes, basically 76% of the system, housing 1,600 virtual machines. Now let's take a look at the same system, the same cluster, but now including the swap efficiency feature enabled on every host. And you can quickly see the amount of space reduction that was delivered here. We went from 7 terabytes to now 18 terabytes, which is basically down to 1% of the system. Now this shows a significant impact on the amount of space that was reclaimed and is able to be utilized for some other reasons, which proves my point on how powerful this particular feature can be used and when it comes to leveraging or looking for the most optimal and the best results when it comes to space efficiency within virtual SAN. And the last thing to wrap it up here is we're going to take a look at the impact in CPU that virtual SAN introduces to an infrastructure when all of its CPU intensive and space efficiency features are enabled. In this particular test here was performed on a VDI infrastructure. And you can take a look and see that based on the amount of resources and the features that are being used, we consume a certain level of CPU, or we add a level of overhead to the system, particularly when it comes to adding all of them, checksum, RAID 5, dedupe, and compression. You can see that at the very end, the overhead introduced to the system, which is already almost tapped out and consumed at almost 100%, is an overhead of 1.39% of overhead when it comes to using the system with all of these different data services enabled. This is very important when it comes to hyper-converged infrastructures, whereas we want to make sure that we don't consume a larger percentage of the system resources to deliver a particular service. This is crucial, right? And it's very important to be able to understand that. And Virtual SAN does this in a very, very efficient way to make sure that you can still use the same sort of consolidation ratios that you intend to for your virtual machines and your CPUs without this particular system imposing a large overhead to deliver any one particular service. For more information and whenever you want to get your hands on and get started with Virtual SAN, there are many options that are available. You can try by contacting your local VMware SC and get a Virtual SAN assessment. You can try our hands-on lab, and if you decide to participate and move on to a hyper-converged solution powered by Virtual SAN, there are many options available, whether they come from engineered appliances or what we call Virtual SAN ready nodes. That's about it, and thank you for watching today's webcast on Virtual SAN Take 20 based on space efficiency features. Thank you, and see you soon.